on this computer. Yes, so yeah, thank you all for coming. I'm sorry we're a bit late to start. It's 7 minutes past 1. So yeah, as I mentioned on the invite, this talk is mostly aimed at system admins, DevOps people, and also Docker enthusiasts. I hope you find the content of this presentation worthwhile. It took me a while to compile it. Unfortunately, I think I'm gonna step up beyond 45 minutes because there's like 50 slides on here, but I'll just try to go as quick as I can. And if you don't mind, hold up the, what do you call this? Hold up the questions and you can just ask me the questions after the presentation, or just type in the questions in the chat and then I'll take them off. All right, so this Lunch and Learn is mostly about security hardening for your Docker environment. And just a recap from the last time we spoke about Docker and cat GUI on the last talk. If you missed it, so we know that Docker runs on bare metal infrastructure and on top of the host operating system that is deployed to. This then allows multiple containers to run concurrently, whichever way. And we know that each container is an abstraction boundary running on an application such as, for instance, ABC. So all of those applications are isolated in that environment. And maybe for the sake of us trying to understand Docker, let's just examine the Docker engine, which sits between the containers and the host operating system in depth. So we all know that the Docker engine consists of the Docker daemon and the Docker client. The daemon is the one that runs the background, while the client is the one that you interact with your daemon, so on and so forth. And the daemon predominantly just manages the containers. And we know that the client is how you interact with your engine through the command line interface. So this, there are three boundaries within a Docker system. As I mentioned in the previous slide, in the previous presentation, there's the client, there's the Docker host, and there is the registry. And the Docker client is the primary way that Docker uses to interact with the daemon, and vice versa by using Docker client. And I mentioned that the Docker daemon and the Docker client all run the same system, but obviously with separate processes. All right. And almost always, when you are creating a new image, you will start with the base image, and then the base image, you will have that tag that says from, which is going to download the latest image if you haven't tagged it. So it will pull that image from Docker Registry. And obviously at that stage, the client sends a remote procedure call to the Docker daemon, instructing it to execute the command to pull the recent image from Docker Hub, which is a Docker Registry store, right? Then when you run a command on your client, like for instance, Docker build, again, the client does this back and forth communication with the daemon. But this case, in this case, it will only pull the layers that are new. Say for instance, you might remember from the last talk where I think I updated one of the requirements, and then when I tried to build, it only pulled one of those requirements, and that's it. And after you've obviously finished building the Docker image, you can do your Docker runs, or you can even commit it and then push it up to your private registry or the public registry. A similar process also occurs when you're provisioning Docker containers. So building Docker containers from images and also provisioning Docker containers. The same process occurs where the client does RPCs with the daemon and so on and so forth for you to create your containers. That's just an overview of the high level system components for Docker and some process isolations. But now, this talk is mostly about security, and in most cases for Docker users, security is the last thing on their hand, right? But then we ask yourself, why is Docker security so important? So we've gone over the core components of pulling, building, and deploying a Docker image in the previous slides, as I mentioned. But for those who don't know, Docker is inherently insecure. It mainly depends on the system, on the host that it's hosting Docker. So if the host is insecure, thereby Docker is also insecure. The other thing is Docker build is designed to execute with root privileges. So you might experience when you starting off with Docker, in most cases, after you install, if you want to run a Docker image, you would predominantly run it with sudo rights. You would say sudo docker build or docker pull. So it runs with sudo privileges by default. And the daemon needs that to establish the namespace isolation. And this architecture obviously poses a severe security since the user may execute any command. And the Docker, the daemon will process it without limitation since we are using root, right? Since we are using sudo and running the images as root. And as we can see, the Docker client, host, and registry are deeply involved with all these Docker operations. So all those three isolated environments are all involved since now you're running your system with root privileges. I'm assuming now your system is insecure. So thereby, all of those three operations are all involved in a non-secure system. And to use this system, each of these components has a technical surface that must also be evaluated for any security engineering standpoint, because all their individual aspects, you need to also isolate them and review their security standpoint from there onwards. And we all know that Docker runs on a daemon. But there is all the other alternatives out there, such as Podman, which doesn't really require daemon processes to launch or manage containers, and all containers are ran as the user, not root. So that's another option. And obviously, Docker and other tech companies are also working on a daemonless build tools. Now, what could go wrong in those three architects, in the client, the host, and the registry? What could really go wrong, you might wonder. So for the Docker client, we evaluated the Docker client using the Stride threat modeling approach. If you don't know more about Stride, I've added a link here for anyone that is interested in learning about Stride. Is a security threat modeling tool. It's divided in 6 items. I can just call them items, where spoofing is one of them. So in the client, the traffic from the Docker client to the daemon or the Docker registry might be spoofed, intercepted, or a malicious actor can replay that communication. But obviously, there's ways to mitigate that issue. That issue by using TLS, and also T of Stride. It stands for tampering. So Docker client can be taken over by an attacker. So you might be sitting on a computer, someone SSHs through your computer, and now they have access to your Docker client. Obviously, this might end up leading to tampering with the Docker file. So someone can just SSH into your system, modify your Docker file, which obviously is used to generate images. And if they have control over your Docker file, then they can just add anything that they want, maybe a malicious package or something like that. The other, the R is for repudiation, sorry. So once the client has been compromised, in this instance, we're talking about SSHing. I've SSH'd into someone's computer without their knowledge. I've taken over the Docker client. I've modified the Docker file. Now I can utilize that to make unauthorized modifications, as I mentioned, which obviously might have an impact on the Docker file and the images and the containers thereon. I, it's for information disclosure. Obviously, the client now may reveal sensitive data about you, your system, and so on. For example, secrets that are hard-coded in configuration files. I've seen instances where a user will have a Docker file and they committed their .env file that contains tokens and stuff like that. I've seen instances where that information is there in the wild, and obviously your Docker file has access to that .secret file, and that then obviously compromises your Docker file security, right? Sorry. The other instance is denial of service. I've had a first-hand experience of this, where an excessive client traffic it's overloaded by the daemon. And this is typically on the same, since the client and the daemon are running on the same system, this forces the client to break, obviously exposing the client. Force it to break and exposing the client. I'll go into more details about denial of service in later slides. And the last E is for elevation of privileges. So in most cases, I've seen this. We also unfortunately practice this, where we run our Docker files as root, our containers as root. This then obviously hinders any security based on that. So you'll find that a user is not provided on the Docker file and the container is executed as root. Obviously, this then has implications in the client authorization and the Docker file. But then, yeah, I spoke about the client. So now, what else could go wrong? Supposedly, after going through the threat modeling on the client, now we have the host. What could go wrong on the host, you might wonder? Still evaluating the Docker host using the stride model. We now look at the Docker host. This is the Docker engine that predominantly is in charge of running containers and images. So the first one is spoofing. So this can happen when a sidecar container gains access to the primary container's namespace with the goal of spoofing the primary container namespace, resulting in an isolation tampering. When utilizing sidecars, you should always be cautious. So if you work with Kubernetes, I know most people work with Kubernetes, in your YAML files, you might introduce a sidecar. Obviously, a sidecar, it's another container that has rights to your primary container. So obviously, if that sidecar container spoofs your primary container and takes over, then you are you have a serious issue, right? The other thing is tampering. So a hacked client might tamper with the daemon configuration, resulting in a misconfiguration. I can log into your system, modify the client, modify some configuration, etc configs. Obviously, that will result in a system misconfiguration. Repudiation. unauthorized changes to the daemon may be made by a user, resulting in misconfiguration. I've had this firsthand where I modified the Docker service, so docker.conf, modified it, added a few arguments in that. Obviously, if I can have access to someone else's system and modify that, then it's a serious issue, right? The other thing is information disclosure. We know that the Docker host file system may be incorrectly configured, thereby exposing sensitive information and then resulting in unsafe defaults. The other thing is denial of service. Daemon memory for running container may be over allocated, leading to a misconfiguration. I've also had this firsthand where now you're running a container without setting resource limitation. I'll show you in the later slide what happened. The last one, elevation of privileges. So if a username is not specified on the container, as I mentioned previously, it runs its root. And daemon privileges may be increased, allowing access to any other container on the same host, and obviously eliminating that isolation in between. All right. So that was what could go wrong on the Docker host and the Docker client. Now you might wonder, okay, so what if I've fixed all the issues on the client and the host? Now what? You forget that, okay, now Docker is divided in 3 aspects. Now you are left with the registry. So what else could go wrong with the registry, you might wonder? Still evaluating using Stride, we start looking at spoofing. So authenticity of images is a serious big concern. And quite recently, Docker has introduced a number of ways to handle that, such as image scanning, and also the recent issue with, I think it's log4j or something, log4something. So they've obviously integrated image scanning and approving that whatever image that you're pulling is authentic. And you might notice in Docker Hub, there is a verification tag to show that, okay, this image has been verified by Docker for you to use. Obviously, if you've pushed your own images there and you haven't verified them and you haven't signed them, then obviously they will remain unverified, which then brings us to this. It's not really authentic. Your image is not authentic and anyone can just spoof it, right? You can put in some libraries, vulnerable libraries, back doors on your images and so on. And obviously this then affects image security. Tampering is also one of the things. So container images can be tampered with, and an attacker may implement a malicious image in the registry. And some organization might be enticed to use it. We've seen instances, I think there was at one time, Nginx was tampered with and people had issues with that. Obviously, Nginx sits between your server and the internet. So then that becomes a serious issue for your organization. Another issue is introducing open source libraries in popular hosted repositories. And obviously this can also affect both image security and open source software security. Repudiation is the other part of the Stride. So malicious images may be committed without authorization by the attacker. Quite recently, there's also been improvements on Docker where now you need to authenticate when you're pushing, you need to have some sort of authorization and authentication for pushing your images. And we've seen this firsthand on PyPy, where anyone can just build a PyPy package, a Python package, and push it to PyPy. And thereafter, people can pull that image, pull that package without really knowing what's really under the hood. You might end up finding that there's a backdoor on the package. So at least with Docker, they've been improving their system and their registry to handle such instances. Information disclosure. So sensitive data such as secrets. I personally have had issues where I pushed images with tokens in them that are hard-coded. Obviously, this is a serious security risk, and it exposes my credential to the public. Obviously, that is a huge security risk. And another thing is denial of service. Docker distribution may not properly restrict the amount of content accepted by a user. Then this then allows remote attackers to cause denial of service. And this could affect your Docker registry. One of the important one is elevation of privileges. So container images permissions may be elevated using privilege. So this is a flag when you're building your images or when you're running your images, you can give it this privilege flag, which then allows the container to communicate back with your host. This is also a serious security risk, but I will go in more detail about that later on. So what now, you might wonder. So with all these issues that I've mentioned in the previous slides, what do you do from here? Excuse me. So then how do you protect yourself against this abuse? Now we look at the Docker client. So first of all, you would need to harden your system. There's the host that is running Docker, and the Center for Internet Security has provided a Docker benchmark hardening guidelines. I've added a link here, so if anyone is interested, we'll be able to download. Unfortunately, it's a 277 page document, but it goes in more detail into how one can harden the system. You're welcome to look at it later. The other thing is to ensure that you always have the latest Docker client. You can see that on my box, the latest Docker, I'm running the latest Docker client, which was released back in January. So that is the other thing. Always update your packages. And unfortunately, with Ubuntu, I don't have any antiviruses, let alone endpoint detections. But I know for a fact, Bitdefender it's been recommended in the past. And also it runs on Linux. Unfortunately, it's a paid service. So one can use that tool as an antivirus and also as an endpoint detection to obviously detect any malicious processes or communication running in the background. I also mentioned avoiding the use of the privileged flag when running executions, or when you're running when you're executing commands or on your container, or when you're running a container. So always avoid that, because now it opens a back door for your container to escape. For the user to escape into your system, right? For the Docker host, now we are talking about how to protect yourself against the abuse on your Docker host. Again, I'll emphasize avoiding the use of privilege flags. Fortunately, in our department, I've never seen anyone using privilege flags, so that's a good sign. And also running containers, one should always consider running containers with resource limitations. This then obviously avoids them getting DDoSed. I had this one container, which is a Jacqueline image that I use. And you can just see when I'm running it, it's hogging my CPU. My CPU is constantly sitting at 100%. This becomes an issue where now my system is I can't really use it, right? So obviously my laptop being a beefed up laptop, it can handle this, then I can kill it and so on and so forth. But I'm assuming if you're using a very low end system, this can then make your system unfunctional, not functioning, right? And other thing is, instead of giving containers full access to your system using the privileged flag, you can just give them capabilities. So capabilities, you give your container to say, okay, I want new container to have access to dev for /dev, for instance, or proc, for instance. I've listed this Docker run reference in here for you to just get an understanding of what these capabilities are. You're welcome to check them out. The last one for Docker host is pretty much either installing SE Linux or AppArmor and enable enforcing mode. And this then obviously protects your Docker environment against your system. And you can see I've already installed AppArmor on my system, and Docker default is enabled and the status is okay. And by default, Docker has a profile which ensures that access to all the network is enabled, and no capability, no capabilities are defined, and also writing to proc is not allowed. So with my container and my setup, I cannot make any changes to proc. I cannot mount proc. I cannot pretty much play around with proc. And obviously there's more. If you really want to learn more, you can visit some of these resources that I've added here. I found that this hack tricks resource, this book was very useful for me understanding and going through this presentation. So now, after you've protected yourself on your client and also on your host, the last one is your Docker registry. So with Docker registry, image hardening, there's image hardening. You need to be sure to handle secrets properly. Quite recently, I remember myself and Anna were discussing this, that we need to move all our secrets and passwords to Vault instead of having them hard-coded in our files. So that is one way of doing it. Alternatively, using environmental variables, putting your passwords or your usernames and credentials on environmental variable, then access them. Obviously, this then minimizes the use of a third-party software to avoid using malicious software to the container environment. Okay, there was a typo there. This doesn't make sense grammatically, but yeah, I'll fix it later. The other recent thing that Docker has introduced in their core CLI, it's image scanning. So there's a tool that runs in the background which uses Snake Engine. This is unfortunately a licensed tool. So if you are using Docker freely, I think you can only do 10 scans for free. After beyond 10 scans, then you have to obviously pay a fee. So the way to use it, you would just say Docker scan. Unfortunately, this is only available on the latest version of Docker. So you can use Docker scan, which then you just scan your image and it will tell you if the image has any known issues or any vulnerabilities. And you can see that in one of my images, I've got a vulnerable path that obviously I'll need to fix on a later stage. The other thing is avoiding the use of images from the wild. I know myself, I've also been, I'm one of those people that you'll just find an image, pull it, run it. that is not really safe. So one should always try to avoid that. And the best way to avoid that is to enable DCT. This is Docker Content Trust. You can enable it by updating this variable and setting it to 1. This then tells Docker to only download verified images from the publisher. And DCT just serves as an anti-spoofing control. As I mentioned, you are welcome to check this link for more. One last thing on the Docker registry, when you pull your images, I mentioned that Docker has recently introduced verification. So when you search whatever image that you find, for you to have a peace of mind, check for this verification icon, and also this log for shell, CVE not being detected. This tells you that this image is secure, it's been scanned, it's been verified by Docker that it's authentic, and then I can be happy with it. So when you pull, thereafter you can verify it. I've added this snippet here to just show that I've verified my Python image 3.10. I verified it that this SHA-256 is the same thing as the SHA-256 that I pulled from Docker Hub. You might get instances where someone might spoof these shells or spoof an image, and then when you compare it, they're not the same. That then just gives you a flag that, hey, no, I shouldn't be playing with these images. Obviously, for an image that is verified, then you are good to go. But if it's unverified, I would really suggest going forward, anyone who wants to or who is really keen on security, always verify the images that you pull before you run them. And how you do it, there's the command, and you can just verify the SHA. Yes, so we are almost at the end of this presentation. So after you've learned how to protect yourself against any abuse, it's always good to also do system audits, because obviously now you've improved or mitigated some risks on Docker side of things. But now, what if your system is prone to any security vulnerabilities? That's where system auditing comes in. So I've played around with various tools, and some of these that I'm gonna share with you are tools that I'm really confident about and that I've played with them. One of them is called Linus. This is a security auditing tool for Linux and Mac and all other Unix-based system. They regularly update their repository, and obviously for you to run it, I've added those commands. They just run system audit. This obviously will then audit your system based on the benchmarking that they have. And it will just tell you, okay, instances like consider hardening your system services and stuff like that. The list is endless. Also for me, it's telling me that there's only 4 suggestions. Fortunately, I don't have any warnings. My system is secure, but obviously I need to look at those suggestions. So this is another one of the tools that I've used in the past. In the previous slides, I mentioned the Center for Internet Security benchmark. They have this document, which I mentioned, that is about 277 pages. They regularly update it, and the latest version is 1.3.1, which I have on this link. If anyone is interested in digging more into this, they're welcome to pull it and read and go through it. When you open it, it will show you this. It's got your profile, description, rationale, the audit, and remediation. So in the previous slides, I mentioned this thing called the DCT, the Docker Content Trust. and then it tells you what this thing is, the rationale behind why you need to enable it, and how one would obviously enable it. So this document goes hand in hand with either one of these tools. So we have Aqua Security Docker Bench and also Docker Bench for security. The Docker Bench for security is Docker's tools, and obviously Docker Bench, it's ran by Aqua Security. These tools, then when you run them, they will give you all those tags. For instance, it tells me that 4.1, that I need to ensure that a user for the container has been created. Unfortunately for this, it's not. And also it's telling me that I need to ensure that DCT is enabled. Obviously, if you go to 4.5 and you go to 4.5 in the document, then it shows you how to remediate your problem. Obviously, after you've remediated your problem, then when you run it again, it won't show you any problems. And here you can just see that I've only grabbed for fails. There were a number of fails. Why are there fails? Because this is a vagrant box that I tested this on. I didn't want to test it on my own machine. I tested on a vagrant box just to get the number of fails. Then after you've run this, obviously we'll just compare and update and look at the remediation. I've added links to where one would find these tools, and you're welcome to check them out. The other one is Docker Bench from Docker. Docker Bench, it's also similar to, Docker Bench for security is very similar to Docker Bench. However, this is something that Docker has created for us end users. And how to use it, you just run this Docker command. You just run this container, and it goes through, it checks your system's vulnerabilities and recommends what you need to do. You can just see here, there's a couple of warnings. There's infos. Obviously, for us, we don't care about infos. Mostly, we care about failures, and we can see that there are no failures in this case. And yeah, I think that's the end of my talk. I hope it was very fruitful. I hope you learned something new. And yeah, if you have any questions, I will gladly take the questions. Thank you. I went as fast as I could to give you this, but yeah, you are more than welcome to check all these references and resources that I've left here for a more deeper understanding. So yeah.
Paul, you mentioned SE Linux. How do you configure it on Docker?
Oh, okay. I didn't really go into much details about configuring it, but I've added these links in here. I'll send out this presentation for everyone who is interested, and then all the details are detailed here for also SE Linux and AppArmor. Personally, I use AppArmor, but yeah, anyone is welcome to use SE Linux.
Okay.
Yeah. If there are no more questions,
I have a question. Sorry.
Oh, okay.
Hi,
Cool.
Paul. I don't know if you mentioned this, but I had a question. So, like, supply chain attacks are quite big right in here, right? Oh, I'll take it. It probably is big. So, as a developer, right, and you want to create your software and run it on, when you created your software and run it on an image, what are the best practices? Because, like, well, I guess that's your talk that you just gave now. But like, have you encountered? So, like, the question is like, if you choose Alpine Linux over like Ubuntu for running your binary or your application, of course, the attack surface is much bigger on Ubuntu than it is on Alpine, right? And these things are going to persist. Like supply chain attacks will always be there. What are the best or things that you just the best things that you came up for, like rolling out your software, like especially like So I think like for Go is easy to like ship on a Alpine Linux because you just need whatever environment that execute me. But like for Python, you have to like fetch all these things. Then you start to maybe fetch some library that you don't know is there. So there is a level of security outside of Docker that you bring in.
Yes.
That you can that you should be aware of before you bring in that. Right. So is that where the Snake and those guys help you with or whatever comes in?
Well, there are best practices. Some of them I've mentioned them in one of my blog posts. So I think this also motivated this talk. I've listed a couple of best practices that you can use, and I've mentioned some of them here. For instance, you could ensure that your containers don't run as root. You could give it Docker username. You could run other packages for scanning your pipe. If you're using Python, you can run packages for scanning Python packages before you install them on your container and then flag them. The other thing is obviously running your containers with resource limiting, and also adding things like app armor to ensure that your containers don't have any accesses to proc or dev or whichever other systems. So there's a lot of best practices, but thank you for bringing that up. I'll just update this with another link that I found where it talks about best practices. Oh, and the other one that I haven't really delved into is building images with multi-staging. So that's another way to as a best practice. Sorry, Tawfiq. Yeah.
No, just a question. I think this is more just developer kind of best practices. That was the thing for this. The other question I had: have you ever encountered something where like a lot of Docker containers load disks, right, or load volumes? Sorry, correct. They load volumes from the server to the thing. Has there any, or have you encountered like reading about these things where people attack the volume you're loading from? Because I mean, that's just an interesting entry point into a Docker container. So if you attack
it's something I've never really delved into. I've never really thought about that. Mostly when I looked into this was mostly an attacker attacking your system, not the other way around, where they can load things on your volume and then attack your container and stuff like that. I've never really thought about that as far. But yeah.
No, it was cool talk. Thanks. And I'll chat again probably about this.
Yeah, we can have a chat. Since you are more into security, I'm sure you know more than I do. I just brushed the surface. So yeah. All right. If there's no more questions, thank you all for being here and spending your lunch with me. I hope you found this talk valuable and some of this content valuable. And yeah, thank you.